Hi and welcome to this video which describes some new features we're considering for inclusion in the LANGuardian product. The LANGuardian implements a full DPI engine so that it analyzes every packet in a span session. The design philosophy is to extract the relevant data from these packets and present it in a high-level summary format and not to store the full contents of every packet. Presenting the data in this way is easy to understand for users that we find in the mid-market, where sometimes the technical ability to do deep packet inspection isn't there. This gives great visibility of how the network is being used and most frequently uses the pages we're looking at in front of us, like the network forensics page or the bandwidth troubleshooting pages. The drill down options from here allow for deeper analysis of events and traffic flows, such as files accessed, maybe how the proxy is being used, or various website pages that are being loaded most frequently. Sometimes we're asked about a more sophisticated alerting and server and application performance troubleshooting. And this video describes how we can exploit the flexibility of the DPI engine to quickly answer these questions. The first thing I want to show you is a new type of alerting in LANGuardian. Here's a page showing three types of rules based on DPI analysis. The first one we look at is a Windows file share rule. So we're looking at all accesses on Microsoft Windows file share to a file called Roadmap 2013. We could add in here actions, so just trigger the alert if it's a file write or a file delete, or we could have accesses to a particular file share. The actions we can take then are to generate an alert, which is disabled, or generate a trace, which is also disabled in this case. The second rule here concerns web accesses. We're looking for accesses to demo2.network.com. So we could include a particular page in the URI here as well to say, look just for software downloads or accesses to a particular page. Again, the alert here is disabled and the trace is on. So the third rule here is a general traffic analysis, which is looking at traffic from a particular source to a particular destination. It's enabled to generate an alert and also a PCAP trace. So let's talk about what a PCAP trace can do. LANGuardian has a facility for uploading PCAP files from external sources and doing an analysis on them. So let's look at the PCAP file page. Here we can see we've uploaded a PCAP file from an external source, maybe from TCP dump or from Wireshark, that concerns a particular incident maybe that we're investigating. So we can click on the process button to process this in the normal way to see what events and traffic flows are in this PCAP file. What I'm going to do now is generate some traffic on the network and trigger the rule we saw earlier with this particular source and destination IP address and see what kind of PCAP information we can get from that. So we've generated the traffic. I just reload the PCAP page and I see here we have a new file called trace21.pcap, and this refers to rule 21 and it contains a packet trace just for that particular session. I can now analyze it using a new type of analysis function in LANGuardian. And this is going to show us a list of all the packets in the flow with various information for each packet. So let's see what the trace contains. We can see here we have a packet number, we have a time difference between the arrival of each packet, and we can see the various flags which are in the TCP packets. We can see source and destination IP addresses, and we can see information about the packet sizes. So at the top here we can see the TCP three-way handshake for the session establishment. There's a delay between the SYN and the return of the SYN-ACK from the remote website, which you'd expect. And further down we can see the first HTTP request, which is a GET of the website. The ACK comes back from the website fairly quickly, but there's a delay then before we see some data arriving from the website, so that corresponds to this delay here in packet number 6, where we see a payload of 1,440 bytes in the packet coming back. So that indicates that the web server itself is introducing some delay here in sending the traffic back. So quite a lot of detailed information here about the various traffic flows and the timings, and you can get an understanding of whether network latency or application latency is causing some of your performance problems. So there's quite a lot of detail in the packet trace here, and we're providing summary detail on this page of all the packets. If we want to look at a packet in more detail, we could click at this link here and it throws up a page similar to this. This isn't the exact packet we're looking at here. It shows us Ethernet headers and IP headers and some of the raw packet information. So you can get a quite detailed view of all the contents of the packet. So to summarize what we looked at here, we looked at some new type of alerting in LANGuardian based on DPI analysis or particular source and destinations, how we can create PCAP traces for saving or later analysis, and a new type of analysis showing packets in flow. The final item I want to look at here is a type of report that does a continuous analysis of session establishment latency in traffic flows. What we're looking at here is network round trip time. In this case, it's the time between the SYN-ACK and the ACK packet when creating any TCP session on the network. We can see here we're looking at internal and external flows, and we can see some quite dramatic latencies here in getting the session established with some remote sites. You can see here up to thousands of microseconds. So if you have this kind of latency in your network, it can indicate performance problems that users might be experiencing. You can isolate network latency from application latency. So that concludes our video for today. Thanks for watching.